Got it. Yeah, no problem.
Hi, I'm Pebbles Turbyville, and I am the Executive Director of the Horses and Humans Research Foundation, and this is part of our webinar series. We are so excited tonight. We have Dr. William Montelpare. Did I say that correctly?
Good, yeah, very good.
And Dr. Laurie McDuffie from the University of Prince Edward Island in Canada. Hopefully everybody's internet will work tonight, but in case it freezes up, just everybody take a deep breath and hopefully we'll unfreeze and keep moving on in the presentation. We are very excited tonight to hear about this study because this is part of the preliminary, I should say, report about the efficacy of equine facilitated psychotherapy on horses and humans dyads. So we're going to be looking, or they are looking, or be telling us about their research about the horse piece as well as the human piece, which is really great for us being the Horses and Humans Research Foundation. So I'm going to turn it over to y'all to start your presentation.
Okay, thank you, Pebbles. And thank you everyone for joining us tonight. We are excited also to discuss our research into the effects of equine facilitated psychotherapy on horses and humans. Before we begin, we do want to acknowledge the Horses and Humans Research Foundation for their funding and for this opportunity to share our research. Even though this webinar is focused on equine facilitated psychotherapy, the information is pertinent to individuals involved in many aspects of equine assisted services. Our results will contribute to the body of knowledge on horse-human interactions in general, and more specifically, this research is important to provide evidence of the benefits of EFP to humans, and also, as a veterinarian, I have a concern to ensure the equine welfare for the horses. So many of you, from the sounds of our little discussions before the webinar started, probably have a lot more experience with animal assisted services than Bill and I do. And you know, of course, animal assisted services are used to promote the well-being of humans. And this is also true for military veterans with PTSD. We know that research has shown positive effects from EFP on symptoms of PTSD that include anxiety and depression. In some cases, it's even thought that the horses provide a unique therapeutic effect for veterans, often beyond conventional therapies. And I know that at Serene View Ranch, where we conducted the research, the counseling team had mentioned that there were times they thought that the equine facilitated psychotherapy seemed to help some of the veterans when other therapies did not. Given that researchers have observed these positive effects for humans, it's important to investigate the influence of these programs on humans further, and also to investigate the effect of these programs on the equine welfare. So the purpose of this research study was to explore the efficacy of equine facilitated psychotherapy on human horse dyads through changes in measures of stress hormones and heart rate variability measures in both the human and horse participants. And at the same time, we measured the PTSD symptoms in the humans and the behavioral responses in the horses. Regarding the study design, we used a prospective cohort approach that consisted of 4 cohorts of veterans and first responders with PTSD. Each cohort was involved in 8 weeks of EFP intervention. And so compared to other studies that have been in the literature, one of the novel aspects of this study was the collection and analysis of the paired data from the human horse dyads. Our research team was made up of researchers, students, and staff from the University of Prince Edward Island and from Serene View Ranch, which is a psychological services provider located close to the university. EGALA-trained personnel from the ranch were led by Caroline LeBlanc, a licensed psychologist. And most importantly, we can't forget the horses from the ranch and of course our veteran participants as a crucial part of the team. So you can see this was a project that required a committed team. It went out over about a year of data collection. And it was pretty labor intense to get the data from both the humans and the horses before and after each session. But the committed team included quite a few students from our university. And we had a variety of different levels of students, including fourth-year honor students, veterinary students, and graduate students. It was an amazing experience for all of them. I think they would say that. They loved going out to the ranch and helping with the data collection. Those that helped with the analysis were very detail-oriented and particular in helping us determine some results. And so they contributed to a great deal to the project. So they got great experience and we got some great work.
Good.
All the EFP activities were conducted in the indoor arena at Serene View Ranch. As you can see here, you see the horses tied up prior to a session. And we were really lucky, given our Canadian winters, that this is a heated facility. So very nice for all of us. Because we're talking about dyads throughout our study, we differentiated our participants as either humans or horses. Our human participants included both males and females that served with the Canadian Armed Forces or the Royal Canadian Mounted Police and who were diagnosed with PTSD. Our horse participants were 8 mares ranging from 5 to 29 years and were a variety of breeds. Horses had been with the program from 1 to 7 years. And of course, they were selected for their relatively calm demeanor. So you can see on this slide an abbreviated schedule of the sessions. And the EFP sessions did focus on grooming and horsemanship and did not include riding. Both a mental health professional and equine specialist were present at all times. However, the researchers were not involved in the delivery of the EFP program. So we were there as researchers to collect data before and after the sessions. And so measures included cortisol measures, oxytocin measures, and heart rate variability, as I had said. We were able to collect saliva from passive drool from humans, and this was used to estimate cortisol and oxytocin levels. In the horses, we collected saliva to measure cortisol. We had to collect blood samples to measure the oxytocin due to the assays we had available. Heart rate variability was measured throughout the sessions using polar heart rate monitors on both the humans and horses. And so what we did for the blood draws, for the venipuncture, we used positive reinforcement every time we had to collect blood for the horses so they would not get averse to the procedure. So although there is evidence in the literature that EFP promotes well-being in veterans with PTSD, Well-being can be difficult to measure. For the most part, previous research is based on self-reported measures. And as such, there's a need for objective data to support the anecdotal data and to advance our knowledge. And we know that this is also a mission of the Horses and Humans Research Foundation. In this study, we use physiological measures representing the response of the autonomic nervous system as measures of well-being in the horses and humans. So in a simplistic view, when the person or animal is relaxed and content, the parasympathetic nervous system would be prevalent. And when the human or horse is stressed, anxious, or fearful, the sympathetic nervous system would be prevalent. Measures of the autonomic nervous system do include heart rate variability, cortisol, and oxytocin. This objective data was combined with self-assessment in the form of surveys for the humans. And as I said, combined with behavioral assessment for horses in the program. Our specific research questions were, number one, does EFP improve the well-being of military veterans and RCMP officers with PTSD? Number two, do self-reports of perceived effect of EFP following a session relate to the objective data? Number three, are the EFP interactions between humans and horses perceived as positive, negative, or neutral by the horse participant? And four, does physiological synchronization occur between humans and horses during an EFP interaction?
Great. Thank you. Now I'm going to begin reporting our findings, and I wanted to include this disclaimer just so that if this data gets out there, that people understand that this is a preliminary analysis of our findings. As Laurie mentioned, we've been collecting this data across a year with our cohorts through a pandemic. And so as we were collecting this data, we stuck with a very specific research design, but collected a lot of data. And so we are working through a number of statistical models and methods for how we will actually conduct our analysis to answer our research questions specifically and within the scope of our original intention for the study. So Laurie mentioned that we measured heart rate variability, and I won't give you a lecture on what heart rate variability is, except that it is a non-invasive technique that allows us to use the rhythmicity of the heart to be able to understand the autonomic nervous system functions from both measuring at a more specific level the parasympathetic and sympathetic nervous system interaction and how it can actually demonstrate for us the stress that our specific participant, our subjects, are incurring under certain types of stresses. So as noted, one of our main measures being in the entire effect of EFP was heart rate variability. And so again, this is used extensively now in a lot of equine studies and especially human studies. We use Kupios software, which is a standard in the methodological approach to calculate heart rate variability based on the R to R ratio. So if you think of a normal PQ or ST or an electrocardiogram wave, we were measuring the R to R waves through the software of the polar heart rate programs. The measures included both the time and frequency domain estimates, along with the point care plots that are representative of both parasympathetic nervous system and the sympathetic nervous system. So in fact, this software allows us to integrate the electrical signal that comes off of the heart rate monitors in both humans and horses. And then we are able to process that electrical signal so that we can measure what's happening under a normal electrocardiogram or a cardiac cycle. So the first measure we used or analyzed for the humans was heart rate. And it was for the humans during the 3 activities. That is at baseline, where they were sitting in the arena prior to interacting with the horses. Second, during grooming, where the clients were grooming the horse that they were matched up with over the 8-week period of the program. And the third time we measured heart rate was immediately after walking the horse, which was near the end of the session. In this graph, you can see that the heart rate following the walk was significantly higher than the heart rates for both baseline and for grooming. We can attribute this increase in heart rate to the physical work of walking or to the psychological stress for these individuals. For many of them, it may have been their first time leading such a large animal. Okay. As I mentioned, we were using Kubio software, and in the heart rate variability evaluation, there are at least 3 different ways to understand what's happening to the cardiac cycle as a function of autonomic nervous system stimulation. The first is the time domain, so we're looking at heart rate and derivatives of heart rate. The second is the frequency domain, so that's the frequency of frequencies, the number of times a number of times happens. Again, a little bit more confusing, but you've heard of hertz in music, so it's a hertz measure. And so in both of those, techniques are used quite often, and they give us a linear approach to what's happening to the cardiac cycle under the stresses that are stressing the autonomic nervous system. In addition, there is a nonlinear technique called the Poincare plot. And the Poincare plot is a technique that we think is as good as the time domain and frequency domain in terms of summarizing what's happening to the heart, and especially the contributions of the parasympathetic nervous system and the autonomic nervous system under the stresses that we were measuring. So, excuse me, as a first step in analyzing the heart rate variability responses across the 3 activities, we focused here on the nonlinear estimates of the Poincare plots to show the autonomic nervous system responses to the activities in the programs. And we measured these on each week. So these graphs represent the responses of the cardiac cycle, the stresses to the system picked up by the cardiac cycle during each week, whether we measured it during baseline, whether we measured it during grooming, or whether we measured it post-walk. And so you can see there was no significant difference within either the parasympathetic nervous system response or the sympathetic nervous system response across the 8 weeks. If we expected to see a difference, we would have expected to see a downward sloping curve in both the, in the sympathetic system, and an upward sloping curve in the parasympathetic system. We did not see that. But what we did see was differences between the baseline and the walk. So in the left-hand graph, you notice that we went from a baseline measure, the parasympathetic system dropped and after the walk. And in the right-hand graph, you see that from baseline to post-walk, the sympathetic system went up, which means that they were demonstrating a perturbation. There was the individual was perturbed after these activities. Were they perturbed because of the physical activity of the walking, or were they perturbed by the stress of now they were responsible for leading the horse around the arena? Okay, so it wasn't that the therapy wasn't working. It's just what was happening when the individuals were exposed on their own to these horses. Okay. In this graph, we see the response of the cortisol system. So in other words, what's happening from our stress hormone system during the 3 phases of the walk and across each of the sessions, or sorry, the 3 phases of data collection. Now, in the heart rate variability, we were able to measure baseline, grooming, and then post-walk. When it came to the salivary cortisol and the oxytocin measures, we measured those 2 specific hormones pre and post activities. So here we see the blue line is the pre-session concentration of cortisol, and the red line is the post-session response of cortisol. So when we review these data for each participant, we see that for the most part, except for week 6, there's a decrease in the pre to post cortisol levels. Okay, something happened in week 6 we're not sure of, but some reason the data, we have a few problem is we have a few outliers that that influence the response of the data. Here we see the human salivary oxytocin concentrations. So oxytocin is the feel-good hormone. So notice from the blue line, which is the pre-session, and the red line is the post-session, that there is an increase in the oxytocin level. But because of the interaction here, the increase was not significantly different for the total group data across the 8 weeks of the session. So what's interesting here is, while we do see the day-to-day variation in these particular responses, we didn't see an overall change, either a drop in cortisol when the people arrived the next week or an increase in oxytocin. Every week they came in with a near normal baseline over the course of the 8 weeks of the program. But while they were in the program, we were seeing a stimulus effect. Next, please. Okay, so now in this graph, this is just one of our participants, and you can see here, these data show up as significantly different for the individual. So because of outliers and because of the lack of the homogeneity of variance, the lack of the consistency in the responses of our participants, we didn't see a strong, significant effect across the 8 weeks. But for individual data, across 8 weeks, we do see this response. To me, that's very important to point out. We're not trying to show a statistical outcome here. We're trying to show an experimental outcome from the oxytocin response to exposure to the EFP, and we were able to show that to some extent. In addition to the hormonal responses and to the physiological response of the cardiovascular system and the autonomic nervous system, we also looked at data that came from the psychologists' responses of very specific surveys. And here we see the daily response to questions about anxiety, mood, and well-being. So here we see the pre-post session estimates for questions about anxiety. And so notice in the data for each week, the responses reported a decrease in their overall feeling of anxiety. So there was a change from pre-session to post-session overall on a day-to-day basis. But we didn't see this complete drop off. They didn't come in the next week where they left the previous week. Okay. So likewise, when we look at, I think you jumped across there. Go back. Oh, mood. Okay, I'm sorry. So in mood, we actually also saw the same kind of a response where we saw that their mood improved from pre-session to post-session. And then likewise, in their respondents' self-perceptions of feelings of well-being, they also increased over the 8 weeks of the program. So on a day-to-day basis, they felt better when they were leaving than when they came into the session on a given day. But the overall slope of the graph did not change. They always started pretty much at the same feeling. Okay.
Okay, so recall our research questions. First of all, does EFP improve the well-being of veterans and RCMP officers with PTSD? So we do have some evidence to suggest there was an improvement in the well-being as supported by the decrease in daily cortisol after the EFP sessions and the increase in oxytocin levels after the daily sessions. And the second question, do self-reports of perceived effect of EFP following a session relate to the objective data? So as we just mentioned, the self-reports showed an improvement in well-being after each EFP session. And this was consistent with our objective physiological measures. However, regarding our measures of HRV, we did not see a significant treatment effect, as Bill pointed out. So we didn't see the effect we expected with the HRV representation of the autonomic nervous system. So, and from a simplistic point of view, we would expect an increase in the parasympathetic nervous system and a decrease in the sympathetic nervous system indices from the beginning to the end of a daily session and over the 8 weeks of the session to show another measure of decreased stress and anxiety as a result of the sessions. But the more we learn about heart rate variability, we know that in real life, it's not simplistic. And certainly exercise and arousal associated with, as Bill mentioned, leading a horse are two important considerations that may have increased both the heart rate and the sympathetic nervous system index during walking. And so there are some of these confounding factors that may have led to our not finding the expected outcome with our HRV measures of the autonomic nervous system. But the important thing to remember is that overall, it's noteworthy that respondents felt generally better after the session each week. And we did have some physiological evidence backing that up. And this was really evident each day when the participants, may have shown up. There are certainly times that our participants showed up at the ranch, not in the best mood, feeling a little bit uncooperative, but by the end of the session, when we were collecting the post-session data, they were in a very good mood, like a different person. So anecdotally, we really saw the difference in the participants.
So Molly, I hope this starts to answer some of your questions, because now I'm going to start talking about the data we found in the horses. And so just as we measured, we began our measurements of our humans with, heart rate responses. Our first measure on the horses was their heart rate response using the polar monitors. I'm not sure if you've used polar monitors or heart rate monitors on horses, but it's not a difficult process, but we did have to practice to get it right. And here we see that there was no significant difference in the heart rate responses of the horse at a baseline measure, grooming, and post-walking in any of the given weeks. So the data I'm using here is the mean heart rate measure that comes off of the polar monitors. And so you can see that the horses are not showing any kind of cardiovascular stress as a function of participating in the 3 activities in the program. To be more precise then, we also looked at those parasympathetic nervous system indices and the sympathetic nervous system indices for the heart rate variability estimates using, again, the point care plots and the nonlinear estimators. And again, those nonlinear estimators provide very accurate responses of what's happening in the autonomic nervous system under different kinds of stress. So here you can see that while there are differences in the 2 systems, and the 2 systems do parallel each other in terms of what's happening. So as the parasympathetic system rises, the sympathetic system falls. As the sympathetic system falls, the parasympathetic system rises. So what happens is, think of the sympathetic nervous system as being your fight or flight system. And so we don't want that system to be profound in our equine participants. We want that system to be moderated. And the moderator of that is the parasympathetic nervous system. So that's the system that is at a high frequency, but a very low voltage. So it's the moderating system. The sympathetic is that I got to get out of here. It's the really charged up system. So that's the system that we want to keep low. And it was low throughout the activities. And it was low and maintained the same pattern right across the 8 weeks of the program. So when you look at the welfare of the horse and you think about what's happening to these horses, are they really holding in a lot of stress? Well, our data indicate that they are not holding in a lot of stress, and their heart rate's response is not showing a high cardiovascular response. Okay, sorry. So Here we see the cortisol plot. And again, here I'm using different graphing techniques to demonstrate what, for us, seriously, we're trying to figure out what's going on here. And here we see that the response of the horse across the 7 weeks of the program, there's no significant difference. Again, across the 7 weeks, when we look at the levels, we see that the measures at baseline are the blue line, and that goes across the graph. And then we see the drop in cortisol on given days. And so as we do see this reduction, and we saw reductions again, when we go at individual horses, we do see different patterns. And this is a graph for the overall response of the total group. So the reduction in cortisol concentration is encouraging because it supports the notion that the horses were not stressed during the sessions. And if anything, there's a reduction in the stress hormone of the cortisol within the time period, okay? And I wouldn't give that up to the diurnal variation of cortisol because of the very short period that people were actually with the horses during this session. So likewise, here is our oxytocin measure. And again, this is group data for the horses across the 7 weeks. And we did not see a significant change in the day-to-day variation, nor in the overall pre to post session variation of the oxytocin for the horses across the 8 weeks. So again, there really didn't seem to be a profound effect on the horses relative to the oxytocin levels.
It was interesting also to observe the behaviors of the horses during the sessions, which we did by using video recordings after the fact. The data that we used were based on this stress ethogram. So this is a stress ethogram, and it's modified from Kaiser et al. And Young et al. And what we did was watch the video recordings and then counted the numbers of stress behaviors during the different activities.
So you can see some of those activities that we're looking at are explained on the right-hand side of this table.
Oh, I should be at radar graphs. Oh, sorry, no. Okay. Yeah, so we counted the stress behaviors of the horses during the activities, and here's a graph of the mean stress behaviors, comparing the behaviors during baseline when they were basically standing in the arena, tied to the arena, like you saw in that original panoramic view. And then during the grooming and immediately after being walked. So in this case, when we compared the average number of stress behaviors during the activities, we found that there actually was a significant increase in stress behaviors immediately post-walking compared to the grooming and baseline.
So if I can just jump in here too, one of the points we've been talking about a lot here is the within group variation of the participants, whether they're human participants or whether they're equine participants. And you can notice that at baseline, there's a very low standard deviation or standard error in fact, in this case. And as they started to perform these different activities, we saw in all cases that the standard error actually increases relative to the participants. So again, we only had 8 horses in the activity, but used multiple times. And so that does exacerbate that standard error bar.
So these are radar graphs, which are really nice graphs that represent the frequency of the stress behaviors during each of the activities. And you can see that head turning, which from the ethogram is described as movement of the head away from the handler, independent of the handler's command. So that's the description. So head turning was the most frequently observed behavior considered a stress behavior during all activities. Now, if you look closely, you can see that on the third graph, post-walking, we see that the frequency of pawing increased. So pawing, now these are subtle stress behaviors, which is a good thing, but they are considered stress behaviors based on the ethogram. But so pawing was the stress behavior that increased the most across the sessions from baseline to walking. So recall that our last two questions were, are the EFP interactions between the humans and horses perceived as positive, negative, or neutral by the horse participant? So remember, every human-horse interaction will be perceived by the horse as either positive, negative, or neutral. Now, our data here showed that the horses did not appear to be stressed, but nor did they appear to have improved well-being based upon the oxytocin. So we would say that the horses probably perceived this stimulus as a neutral stimulus. Okay, so let's see. Oh, of course, sorry about that. Except you would say, well, what about the behavior? So physiologically, they did not appear to be stressed. And so we say from the physiological evidence, they probably perceived the interaction as neutral. But then we did have the behavior, the stress behavior of pawing that increased. So this is something we need to look into further. But it may have been that the horses knew that the walking indicated the end of the session.
Mm-hmm.
And so it may have been simply anxious to get turned out and finish the session. So we don't know for sure. We need to investigate that further. But that's one, horses are very smart. Of course, they're going to know after probably after 1 week, that post-walking means they're going to get the sessions over. So that's one possibility. And then, of course, the fourth question was, does physiological synchronization occur between the humans and horses during an EFP interaction? Which is really one of the really intriguing questions, because personally, when we started this, there's all kinds of theories out there why animal-assisted therapy works, or why it's beneficial. And one of the theories is that synchronization occurs. So we wanted to look into that a little bit.
Right. So this is really interesting. I think as a physiologist, I'm really interested in this notion of, is it entraînement? Is it synchronization? Is the horse and are the rhythms of the horse and the rhythms of the human coming together in some regard? So that's what we're trying to measure in terms of a synchronization. So how do we do that? So as my area is, I'm a biostatistician, so I'm thinking about how do we measure this, not in a correlative measure, that would be wrong. We're trying to look at it from a measure of agreement. So on the question of synchronization, we can see that there are two images here, and there appears to be some coordination of the physiological activity as a function of the horses and the humans interacting from an agreement perspective. Okay, so the graphs use a technique for measuring agreement based on what we refer to as a 95% confidence interval. The image on the left shows a strong agreement between the horses and the humans for the change in cortisol level from pre-session to post-session. We don't know what the pure cause of it is, but we do see that there is agreement in the synchronization of those two responses. And then likewise, the image on our right here, it shows the strong agreement in the changes in the point care plots for both the, sorry, our notes are all over here, for the estimates from the HRV. In terms of looking at what we refer to as the SD2, the standard deviation 2 over the standard deviation 1. And the standard deviation 2 is the ratio, the SD2 to SD1 is the ratio of the sympathetic to parasympathetic system. And we see that there is agreement in both of these curves by the human and the horse at the same time. So these green dots represent the pairs of horse and human dyads. So what's happening to the horse is also happening to the human in some regard, in that there is agreement from a statistical perspective, but what is the cause of the agreement? In this case, it's exciting because we are looking at the agreement in both a hormonal response and an agreement in an objective measure of the cardiovascular system, being the point care plot for heart rate variability. Excuse me. So we did create a summary statement to hopefully pull together a lot of where we were going with this. So from the findings to date, we think that there is a beneficial effect of the EFP program on the responses of individuals with PTSD, while having no concomitant negative physiological effect on the welfare of the horses. We also think that there is a need to investigate the behaviors of the horses further, as we did see a perturbed response in the horses following the walk. We think that the state versus trait response of the individual is a confounding effect that might not be captured in this research, given that most of the human participants had very little to no experience with horses prior to their involvement in the program. Hence, some of the responses we are measuring may be a function of how the individual perceives their direct interaction with this large beast. We also think that our next goal is to change the dose response dynamics of the program by extending the program beyond 8 weeks and exposing the individual to more than once per week. We're also considering including other measures of well-being beyond both psychological and physiological outcomes, and how these outcomes are influenced by the medication regimen of the participants with severe PTSD. So, and with that, we'll open it up to questions. Thank you very much.
My first question or first thought is, I wonder if those horses would change if it was a person that had horse experience, like someone without PTSD, if their behavior would change versus like I guess these were beginners or didn't have any horse experience. So that's the first thing I'm thinking about. I wonder if their behavior would change at the end of the session or with walking if they had someone who had horse experience.
Well, I think there is literature on that, where it shows that experience was a major factor, not the condition of the human or the psyche of the human. Yeah. So I think you're right. And I think there's some data in the literature on that.
Was there a base level of the degree of PTSD with the veterans that you chose, or were they on all different levels of degrees of PTSD?
The latter. They were on, to the best of our knowledge, they were on different levels they had different levels of PTSD, and they may have been on different medications and different levels of exposure to the therapy as well. So again, this is a great preliminary study, and one that helps us to understand that there are interactions happening between horses and humans in equine facilitated psychotherapy, but this is no way at the population level.
I think your discussion about checking about the medications is really important, because there's an economic impact. If you can say they went off meds, and when they were taking 5 meds and now they're taking 5, that has a huge public response, even if it may not be quite as scientific, but it's a great PR way to look at it.
Yeah.
Right.
Can I add to that comment, Molly? Because I think that is something that's very important in terms of understanding their change in medication and whatever their regimen is. Likewise, one of the really exciting things that came out of this study from my perspective is I'm a member of the board for the Canadian Institute for Military Veterans Health Research. And one of the questions they're asking is, do we support the use of animals, either canine therapy, equine therapy, for individuals that are returning from combat? And where is the objective data to support those individuals? So from an economic perspective, again, how is there enough objective data to say that the Veterans Affairs should be providing direct animal support for many individuals that are suffering from PTSD? And does that replace the use of narcotics or other kinds of pharmacological medications? That adds to your argument.
Yeah, it's an important piece.
Mm-hmm.
We have a question in the chat box from Suzanne. She wanted to know if did you look at the different kinds of horsemanship activities and whether the horse stress levels varied with those activities?
Well, so that's what we were attempting to do by having two different activities. So the baseline, that's their pre-session data. Just again, in the arena, waiting for the session to start. Grooming would have been, obviously, when the veterans were grooming them and they were still tied up. And then they were led around the arena. Sometimes you saw the obstacles in the one image of the arena. Sometimes they would have to do more than just lead the horse around. They might have to lead them through obstacles. So we did look at, we could only get the cortisol and oxytocin before and after because we didn't want to interfere with the sessions. But the heart rate variability data went throughout the whole session. So that was our chance to try to look at what was happening with the autonomic nervous system throughout the session, during grooming and during walking. So we didn't see any difference, as you saw from the original plot that Bill provided with a sympathetic and the parasympathetic nervous system indices. It didn't change with activity. So according to that data, the different activities did not cause different stresses. But now, according to the behavior ethogram, find that nice SNS one. According to that behavior ethogram, we'd have to say that post-walking caused an increase in the stress behaviors. So no difference in the heart rate variability measures during the sessions between the different activities. But again, the behavior is a little bit confounding. So that was our attempt to look at stress during the different parts of the horsemanship occurring.
So just to emphasize that every session consisted of grooming and leading, correct?
Yes.
Yeah.
Okay. That was a question in the chat box.
Well, so to be perfectly honest, session one, as you might have noticed from the schedule of events, was an orientation session, and they might have had 10 minutes with the horses. So we talk about 8 sessions. You see most of our graphs have 7 sessions. So the majority of the interactions where it could be considered an intervention happened starting at week 2.
Okay.
Okay.
There's another question as far as were the same veterans and horses paired each session?
For 8 weeks, they were as close as they could to being yes. So if I was Joe in the program and I had Gumshoes as my horse, I don't know. When that Gumshoes was my horse for the whole session.
Poutine.
Yeah, Poutine was one. But again, if I'm afraid of horses, doesn't matter who my horse is, I'm getting used to the horse over time, Well,
it was interesting because in some of our data, one of the graphs we had made, like week 2 spiked where one of the indicators of stress in humans. And of course that week 2 was really their first week having to do a lot with the horses. and then that came back down. So it is really interesting that to look really carefully across the weeks and the activities. But it certainly makes sense if the first week doing a lot of interaction with the horses could be a bit stressful. And then over time, you know, they do, of course, they do get comfortable with their horse. They write little, you know, at the end of the sessions, sometimes they would write little notes about how it went with the horse. So we knew that they were certainly developing a relationship.
And I have another question as far as it's coming through the chat box. These aren't my questions, but I do have a lot of questions sometimes. But anyway, were any counseling conversations going on through leading and grooming?
Well, we were not in the sessions. Caroline, if you're still on, you might want to speak to that. There was some mindfulness breathing, or if Philip's still on, he could speak to that. I don't think it was considered, I guess I would say it probably wasn't counseling per se, but there was, as you saw from the schedule, some mindfulness breathing.
Okay.
And yeah, if anyone from the ranch wants to make any other comment, they can.
Yeah, hi, this is Caroline. And
Caroline.
no, there was not any therapeutic interventions during the walking. I think it would have been just following the clients and continuing the activities. And what we tried to do was to make the activities as simple as possible so that we could really see what was going on between the horses and the humans.
Well, that is a question that came through the chat box. It said, in your schedule, you list horsemanship activities, and they're curious about what those were.
I think it just refers to the leading. So they're either leading the horse around, getting comfortable leading the horse, or as Egala does, well, they have some obstacles there. The horses weren't free, but you know, they may have had to lead the horses around some cones or something. So that's what the horsemanship activities were, in my understanding. Yeah.
Okay. Is there any reason, and here's another question in the chat box. Is there any reason why all mares were chosen as opposed to a mix of mares and geldings?
Well, we did let the ranch team choose the animals, and I think basically they just have more mares, and they might even have all mares. But so, you know, we said the horses were chosen for calm demeanor, and yeah. So I don't think it was any specific reason. It was just the majority of the horses are mares, and those are some nice calm ones, and most of them had experience with that type of work.
Another question would be, would you expect counseling conversation to change your data?
Well, I mean, like Caroline said, when we were setting up the study, you know, we really wanted to find out if it's the horse that's making the big difference. So yeah,
there was counseling going on, but when the person was with the horse, that was where we were measuring. That's where we were getting very excited to see, is the horse the stimulus for the response of the individual? And so I don't know how counseling conversations would have happened unless there would have been a second person with the horse and the client, so to speak. There's a study in Edmonton, Alberta, where they actually monitored a person walking. These are PTSD, again, PTSD military veterans who walk with horses and talk about trauma. You couldn't have a counselor there. You have the person talking to the horse, and their horse becomes the surrogate for who they are speaking to about the trauma. So would it change the data? I think it would be a completely different kind of study, Christy.
Gotcha. Another question Tara has is basically, what was the quality of the connection between the participants and the horses?
Well, sorry. I mean, one of the most fun things was to hear the equine specialist and the human specialist counselor that were running the sessions, to hear them tell their stories about the horses and the humans. Pretty amazing. And
Wow.
like one of them I remember was that one of the humans came on an off day to maybe do one of the surveys she had missed or something, and they said the horse came galloping up, whinnying. So,
Wow.
so yeah, to hear those stories, it's pretty amazing. We're trying to capture, the more objective data,
Mhm.
but that's the type of things that they were seeing.
Yeah, that's to me why the notion of whether it was an entraînement or whether it was some kind of synchronization of these very specific psychophysiological responses was happening. And again, this is not new stuff. Weber and Fechner and Stevens' laws, these are all psychophysiological responses that are measured in nature. And so we wanted to see if there was this dyad partnership that emerged as a function of these individuals who were, recovering from trauma, and the horses who became their surrogate in the therapeutic modality. So it's very exciting that way.
Yeah. So can you tell us a little bit about part 2 that you are going to do in February? And we don't have a date in February yet, but we'll be announcing that soon. But can you give us a little tease about the follow-up?
Yeah, I can. I'm going to just get down. We're probably going the wrong direction here. Yes, here's the teaser that we put together. So again, we're pretty excited about how all of this stuff comes about, and we find ourselves very immersed in how we're going to make sense of these data. So one of the things, as Laurie mentioned earlier, we've been doing a number of studies in understanding the human-animal bond, and not just equine facilitated psychotherapy, but understanding what happens to the stress of horses when they come into surgery. So Laurie's a large animal surgeon. She does a lot of surgery on horses, and she wanted to know what happens to the stress. Can we measure stress in horses? Likewise, we're looking at what does the horse think when they're asked to be a participant in an autism riding program or in a special needs program? How does the horse feel about all this? And we're talking about horses because that's who we're interested in. But the same sort of thing with canine therapy. A dog wants to lie on its back on the couch when you're not there and stare at the ceiling. It doesn't want to be taking you on all your stresses, right? So we're interested in that as well. So as a statistician, I'm trying to figure out how Laurie shows up in my door with a pile of data and says, okay, let's make sense of this. And I'm thinking, how the heck do we do that? So we've come across a number of very exciting ways of trying to ask different kinds of questions, the way you're asking questions this evening, and trying to figure out what are the ways that we can actually process a lot of the data. We've published now on the reliability, the statistical stability of heart rate variability. So you're talking about variability, which is up and down, it's variable. How do you measure stability of a measure that we're saying is actually variable to begin with? So we've published on that in that area, and we've now just published on what does the horse think about being a participant in a Joyriders program where they're working with children with special needs and what is the stress of those horses. And we've published on the area of stress in horses under cross ties and in the stall and so on. So our next webinar will be to look at the statistical consideration that emerged in our horses and human research, and especially with regard to the EFP, because we find this to be tremendously exciting in terms of the data we have. And so, for example, while here we're introducing the concepts of synchronization, having dyads, how do these partners come together? In the second webinar, we want to review the methods to calculate the measures of agreement between the selected objective and subjective measures that help us to understand the effects of the EFP program on the well-being of the horses and the human. So hopefully we'll get at that question, Molly, you were asking about what's going on in terms of behaviors. And we have other studies to draw from that support the work that we're doing, especially the work with our graduate students who have completed studies on stress in horses and how they observed the stress in horses and the pain in horses. And how do we get a measure for pain in a horse? Horse doesn't tell you they've got a sore foot, but well, Laurie can tell you because she's a surgeon. So.
Yeah.
Well, the thing is, like, all of us can tell if the horse is, non-weight bearing lame, or all of us can tell if the horse's heart rate's 80 and sweating, but we're trying to find more ways to measure more subtle stress, like the stress ethogram. If the horse is rearing, then it's, a no-brainer, right? But there's a lot of more subtle signs that we need to pay attention to, so the stress doesn't escalate to one of those behaviors. Mm-hmm. So we're trying to find measures of more subtle changes, mm-hmm. Because it's easy to note the obvious changes.
Mm-hmm. And then from there, we want to be able to build tools, which we're developing now, so that other individuals can see when a specific behavior is demonstrated by the horse. And so we've got our vet students working with us in terms of being able to say, do you recognize these kinds of behaviors in a horse, so that they're more prepared when they're out in the field. So again, this all flows together.
And we had a grad student in engineering working on a stall side cortisol sensor. Mm-hmm. So we're moving towards trying to be able to have practical applications also.
So the practitioner understands. So it's the knowledge translation pieces are where we're really excited about. So what does all this egghead science stuff mean to the person that's in the stall? What's going to change, right? And what is the value of some of these measures that are being used? Well, everybody's throwing a heart rate monitor on the horse. Do they really understand what this data is telling us? And in particular, one of the things that we're interested in is, let's see if I can get this right, is here, for example, this is a good example of our oxytocin response. And here you can see what's happening in terms of the coefficient of variation and how much variability we actually see in our samples. So, we're getting some positive responses as we would expect, but then we have outliers. And so how consistent are the data that we're collecting across our cohorts within our different kinds of studies, which makes it tremendously exciting for us to continue to explore the data that we're getting, and then to move that to a knowledge translation perspective for the practitioner.
And the other thing that we want to do, or personally what I would like to do, we talk a lot about stress because that's something that has been, studied a lot in the research, but really we want to be taking measures that will represent positive affective state also. So oxytocin was our first try at that, but really, if I started from the beginning again, I would have an ethogram with behaviors that show a positive effect in the horses also. So we need to try to broaden out away from just negative affective states to positive, and see what measures we can use along with oxytocin. And that can be behavior measures also,
Wow. So Suzanne said in the chat that she really appreciated your concern and exploration and measurement tools around the well-being of the horses. And thank you for doing this work.
You're
most
welcome.
Yeah, it was fun for us. It's really
So
exciting.
I wanted to say thank you for showing us your preliminary data, and we look forward to talking with you again in February about the part 2 of your study.
Great. Thank you very
Great.
much. Looking forward to it. Thanks,
Thank you
everybody.
very much. Okay, bye.
Bye.